Hello everyone, my name is Dr. K.C.H. Apparao, working as an associate professor in Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. Okay, today I would like to explain about abnormal combustion of ICE engines. So in previous classes we discussed the normal combustion process, various combustion process in ICE engines, mainly in SI engines, in C engines also, compression ignition engines also, we already discussed. Okay. In this class, especially abnormal combustion process, what are the drawbacks of abnormal combustion? So, what are the different factors which are influencing the abnormal combustion? We'll see all these things. Okay, before going to our lecture, we'll see our course outcome, especially for this topic, mainly unit first. Okay, so at the end of the course, students should be able to classify the fuel injection and ignition systems to predict to pretend the application of combustion chamber types such as T head and overhead based upon the different combustion processes. Okay, we know that IC engine is a heat engine because it converts the chemical energy of fuel into mechanical energy or heat energy. So you know that combustion based upon the combustion, if the combustion takes place outside the cylinder, we call them as external internal combustion engines. If the combustion takes place inside the cylinder, then we call those are internal combustion engines, IC engines. Okay, so if the combustion takes place outside the cylinder, external combustion engines. If the combustion takes place inside the cylinder, so those are called internal combustion engines. We know that the internal combustion engines mainly two types. One is the SI engine, another one is the C engine. We know that SI engine is the spark ignition engine. It means ignition or combustion takes place by the effect of spark plug, because spark plug gives the ignition and combustion will start in the cylinder. Okay, so we already discussed about SI engines. You know the process of combustion in C engine also, by compression of the air fuel mixture, auto ignition occurs in the cylinder. So due to that effect, combustion takes place. You know this one. All these things are in normal combustion process, but we'll see abnormal combustion process. Right? So abnormal combustion process occurs when combustion process deviates from the design or expected behavior, leading to efficiency losses, loss of IC engine efficiency, and increased emissions also, output or exhaust unburned particles also. Next to possible engine damages. So a lot of possibility is there for damage of engines, especially piston top surface or inside of cylinder surfaces also, piston rings and something. Next, the nature and causes of abnormal combustion differ in S engine and C engine. So we'll see. So there are so many factors which are influencing which are causes for abnormal combustion process in S engine. Similarly, there are so many factors which are influencing the abnormality of the combustion in C engine also. We'll see. Knocking. So this one is the very dangerous effect by abnormal combustion process. Detonation. So it is the main drawback of abnormal combustion of ICE engines. So we'll see what is the cause, what is the reason behind this one. You know this one, end gas, otherwise unburned mixture. So auto ignites due to high temperature and pressure before the flame front reaches. We know this one in the normal combustion due to the effect of this spark plug. So the spark plug gives the spark. Due to this spark, ignition takes place. Due to this effect of the ignition, automatically combustion will start. So the flame will start. This combustion, due to this combustion, the flame will expand or propagate from this point to throughout the unburned mixture. So in this way, the systematic propagation of flame uh, forwarded to burn the unburned air fuel mixture. So this gives the peak pressure. You know this one. This is the after TDC. This peak, we will get the peak pressure is after TDC, very near to TDC. We already discussed this one. So this is the peak pressure process. Okay. So this one is the required combustion process, normal combustion process. Okay, so combustion takes place by effect of spark plug, and that the flame will start. That flame propagation occurs to the end of this combustion process. So due to this flame propagation, remaining unburned air fuel mixture also will burn simultaneously. So a gradual increase of pressure will occur here. Okay, so peak pressure will occur after TDC, very near to TDC, like this. So we know this one, that combustion process. But in abnormal combustion, what will happen? We'll see. Okay, so at the end gases, uh, auto ignites or end fuel auto ignites. Suppose this is the cylinder. So this one is the spark plug. Due to the effect of spark plug, ignition takes place. The combustion will start. The flame propagates like this one, propagation of the flame. Okay, so due to this combustion process, high pressure and temperature will release. This high pressure and temperature will pressures the unburned air fuel mixture here. Okay. Due to this high pressure and high temperature, the unburned air fuel mixture burns or uh, burns automatically without any help of this flame propagation. Without any help of this flame. Okay. So self ignition will occurs here without any effect of spark ignition or flame propagation, which starts from the spark ignition. Okay. So this due to this self ignition, so here we will see high pressure and temperature will release. So one is the gradual increasing pressure and temperature, another one is the just in opposite direction, another pressure wave will occur. Okay, so due to this two types of pressure waves, we can see here. So due to this effect, automatically we can't get the highest peak pressure. So sometimes this peak pressure will occurs before TDC and very near TDC also, like this one. Okay. So due to the effect of this one, automatically the expansion, we can't get the good high pressure, high thrust force to move the piston from top dead center to bottom dead center. So efficiency of the engine will reduce due to the effect of auto ignition or knocking or detonation process. Okay. So you see, knocking is due to auto ignition of the end portion of the unburned charge. So this is the unburned charge. Actually, this fuel will burn by the effect of flame propagation, which starts from the spark ignition. But without reaching this flame propagation, flame to unburned fuel, the unburned fuel will ignite selfly, so automatically. So auto ignition. So due to the effect of auto ignition, here gradual increasing pressure is there. Another pressure wave will occurs. Okay, so that pressure wave will spoil the uh, engine, or will spoil the surface of the piston, or inner surface of the cylinder also. Okay, so as the normal flame propagates, so this is the normal flame propagates across the chamber, pressure and temperature of the unburned charge, the unburned charge, the pressure and temperature of the unburned charge will increase due to compression by unburned portion of this charge. Okay, so this unburned compressed charge may auto ignite under the certain temperature conditions. Okay, so automatically it releases energy at very rapid rate compared to the normal combustion process. Okay, so this one here also high rapid temperature and pressure will release. So this is the just like normal combustion. Due to the normal combustion, we will get the gradual increase of pressure and temperature increases. Okay, so there is some contradiction, uh, because there two types of pressure waves will see here. Okay, so that one, that is called knocking or detonation. We'll see this rapid this rapid uh, pressure release of energy during auto ignition, that causes the high pressure differential in combustion chamber. Okay, high pressure wave is releases due to the effect of auto ignition. Okay, that pressure wave spoils the top surface of the piston, and just like inner surface of the cylinder also. Okay, so the motion of compression waves, high pressure compression waves inside the cylinder, that causes the vibration of engine parts. Next to pinging noise, some types of noise uh, will uh, we can audible, so we can listen that one up. So this is known as knocking process. What is the knocking process? Due to abnormal combustion process, due to auto ignition of the uh, unburned fuel at the end of the cylinders, which is placed at the end of the cylinder. Okay, high pressure wave will releases, and high noise, pinging noise will occurs. So due to this high pressure wave, so that some will experience or this high pressure wave causes the vibration of engine parts and pinging noise also. Okay, so that is called knocking or detonation. So detonation is undesirable effect. So as it affects the engine performance, because it spoils the engine engine's parts, mainly piston surfaces, and next to surface of inside the cylinder head also. Next, it spoils it affects the engine performance because of two types of the pressure waves. So engine efficiency will decrease. Next, life of engine will reduce because of this pressure wave. It spoils the piston surface. So due to high pressure wave, the surface of the piston will be deteriorated. Okay, so it abruptly increase the sudden large amount of heat energy. So high amount of heat energy and high pressure. So due to this uh, the parts of the engine will be spoiled. At the same time, the efficiency of the engine is decreases. Okay, it also puts a limit on compression rates also, so at which engine can be operated, which directly affects the engine efficiency and the output also, because it limits the compression ratio. So due to effect of the compression, automatically that leads to effect on engine efficiency and output. So here we'll see. So this is the normal combustion process, required combustion process, because combustion starts at the spark plug, near the spark plug, by the effect of spark, which gives this spark plug. So due to this spark, ignition will start, then combustion will start. So then the flame, this flame propagates gradually throughout the uh, cylinder volume, throughout the cylinder volume. It means due to this flame, the unburned fuel burns by the effect of this flame propagation. So this is the, in which we will see gradual increase of pressure. So the peak pressure we can experience, we can see after TDC. So that is very important, required thing, that is after TDC and very near to TDC. So here peak pressure will occur like this one. So this is the required combustion process or normal combustion process. But abnormal combustion process, we'll see. Abnormality means due to the effect of the spark plug, ignition start here and the flame propagates like this one. Okay. So due to this combustion, high pressure and temperature will release. Okay. This high, due to this high pressure and temperature, so this unburned fuel, due to the effect of this high pressure and temperature, this unburned fuel ignites selfly. So self ignition occurs without any help of the flame, without any help of the spark ignition. So due to this auto ignition, automatically high pressure wave, high temperature will releases. So this high pressure wave and high temperature will spoil the surface of engine parts. Okay, so this is the process. Okay, you can't see the uniform rise in the pressure. So this type of just like zigzag type pressure. So different types of pressures, two types of pressures will experience here. So this is the just like abnormal combustion. This one is the normal combustion. In abnormal combustion, so one type of sound, pinging sound will listen, and that unwanted pressure wave spoils the surface of engine parts also. Okay. Now we'll see auto ignition. So already discussed this one. So a mixture of fuel and air can react spontaneously and produce heat by chemical reaction in the absence of flame. In the absence of flame, it means without any uh, flame or without any ignition process. So the unburned fuel so ignites selfly. Okay. So that is called auto ignition. So this type of self ignition in the absence of flame is known as auto ignition. Self ignition without any uh, effect of flame or ignition process, ignition systems like spark plug. Okay. So self ignition occurs. So that is called auto ignition. The temperature at which the self ignition takes place is known as self igniting temperature. Okay. The pressure and temperature rapidly increases due to auto ignition. So because of sudden release of chemical reaction, you know this one. Okay. So this auto ignition leads to abnormal combustion, that is known as detonation. Okay. Detonation, which is undesirable because uh, it's a bad effect on the engine performance and life. Okay. So because this detonation or this knocking will spoils the, or will reduce the performance of the engine and reduce the life of the engine also, and spoils the uh, engine parts. Okay. So it abruptly increases the sudden large amount of heat energy. Okay. In addition to this knocking, knocking puts a limit on compression ratio, because this knocking influences the compression ratio. So if the compression ratio influenced, automatically the engine efficiency would really would decrease. Okay. So pre-ignition. So pre pre-ignition. Very similar terms, auto ignition and pre-ignition. Okay, pre-ignition means suppose this is the spark plug, this is the cylinder. Ignition starts by the effect of the spark, which is released by spark plug. So that is the abnormal condition. But sometimes, due to high temperature of the spark plug and just some valves also, due to high temperature of the valve temperature, valve surface temperatures, and spark plug surface temperature, due to the effect of temperature, so due to high temperature, without any ignition process, the air fuel mixture will burn selfly. So that is the pre-ignition process. So pre-ignition is the ignition of the homogeneous mixture of charge as it comes in contact with hot surfaces of spark plug, hot surfaces of the walls, and hot surface of the cylinder surface also. So auto ignition may overheat the spark plug. Due to the effect of auto ignition, the temperature of spark plug and exhaust valves will increases. Okay, due to high temperature of spark plug and exhaust valves, so pre-ignition also occurs. Okay, so it remains so hot that its temperature is sufficient to ignite the charge in next cycle. So due to the, it means auto ignition leads to pre-ignition. Due to the effect of auto ignition, the temperature of spark plug surface and exhaust valve surfaces would increase. Mm, Due to this high increase of temperature, that leads to pre-ignition process. Pre-ignition process means ignition occurs selfly without any effect of spark plug, without any ignition process. Ignition process means spark which it gives the spark plug. Okay, next, pre-ignition also caused by uh, persistent detonation pressure. So this one, pre-ignition. Due to the pre-ignition, sometimes the peak pressure will occur before the TDC. Before the TDC, that leads to bad experience of piston because before TDC means the piston moves in upward direction. Okay, after TDC means the piston moves in downward direction. So the pressure acting in downward direction, the piston moves in upward direction. So that is not helpful and useful thrust. Okay, so because of this pre-ignition, so many drawbacks are there. So many mm, defects or so many damages are there. Okay, we'll see. The pre-ignition also caused by persistent detonation pressure, shock waves scoring away the stagnant gases which normally protect the combustion chamber walls. Okay, so this is the just like process of pre-ignition system. You know that. Next, we will see effect of pre-ignition system. We'll see. It increases the tendency of detonation in engine. Okay, pre-ignition leads to so tendency of detonation in the engine. Okay, it increases the heat transfer to the cylinder walls due to pre-ignition. The heat which released in the combustion process, abnormal combustion, the cylinder walls will take the heat. Heat transfer takes place from combustion to walls and or the combustion to spark plug, combustion to exhaust valves. So it means due to this pre-ignition, temperature of the surface of the spark plug, and the surface of the exhaust valves, and the surface of the cylinder walls would increase. Okay, it increases the heat transfer to cylinder walls because high temperature gas remain in contact with the cylinder walls for the long time. Okay. Next, pre-ignition in a single cylinder will reduce the speed and output also. Okay. So automatically this abnormal combustion leads to reduction in the speed and output, power output also. So pre-ignition may cause seize of the piston in the cylinder, okay, due to the effect of what is that detonation. Um, Automatically that piston will seize in the cylinder. Okay. So these are the main effects of pre-ignition processes. Next, so effects of detonation. The harmful effect of detonation are mainly noise and roughness. We'll see some types of impinging noise, and we can listen the pinging type of noise, some type of uh, different type of noise we can listen. Okay. So roughness, knocking produces loud pulsating noise and pressure waves. Okay. So these waves vibrates the engine cylinder also. Next, the presence of vibratory motion causes the crankshaft vibrations. Okay, so the engine runs roughly. So this is the effect of detonation. Next, mechanical damage also you can see due to the effect of detonation. High pressure waves will release due to the effect of detonation. You know this one. So this high pressure waves generated during the knocking, so can increase the rate of wear of the parts of combustion chamber. Wear on piston surface, and wear you can see wear rate in engine inside the surfaces also. Several severe erosion or damage of the piston crown or surface you can see by the effect of detonation. Cylinder head also, damage of cylinder head. Hmm. So inlet and outlet valves. Okay, so damage on inlet and outlet valves also. So there are so many problems, so many damages will occur due to the effect of detonation. Okay, in small engines, knocking noise is easily detected, and the corrective measures can be taken. But in aero engines, big engines, so it is difficult to detect the knocking noise. Hence, corrective measures cannot be taken. So that leads to big damage. Hence, severe detonation may persist a long lifetime. Next, to carbon deposits also. So detonation results in increased carbon deposits. Okay, due to this detonation, unburned fuel particles form in the inside cylinder surfaces. Next, increase in the heat transfer. You know that due to this knocking, so high temperature and pressure will release. The temperature will be taken by the surface of the cylinder, or surface of the spark plug, surface of the walls also, inlet wall and outer exhaust walls. Okay. So knocking is accompanied by an increase in the rate of heat transfer to the combustion chamber walls. Okay. So the increase in heat transfer is due to two reasons. The reason is that maximum temperature in detonating engine is so about 150 C, so higher than non-detonating engines. So automatically this high temperature will lead to damage of the engine parts because of over temperature. The properties of the mechanical properties will decrease of that part also. Next, decrease in power output and efficiency. So due to increase in the rate of heat transfer, the power output as well as the efficiency of a engine will decrease. So next, pre-ignition. So pre-ignition, increase in the rate of heat transfer. Due to the heat transfer rate, automatically pre-ignition occurs. You know this one. Okay. So it may cause local overheating, especially for the spark plug and valves also, exhaust valves also. which may reach a temperature higher enough to ignite the charge before passage of the spark. So that causing the pre-ignition. We'll see the various engine variables affecting the knocking. Okay. So temperature factors and density factors also, time factors also, okay, composite factor. So due to these factors, there is a chances to get the knocking. We'll see what are the different parameters. Okay. The first one is the temperature factors. Okay. Increasing the temperature of the unburned mixture, so increases the possibility of the knocking. Okay. You have to maintain certain temperature. More temperature leads to detonation process. Next, raising the compression ratio. So raising in the compression ratio, okay, gives the good output, but over compression ratio leads to detonation or knocking problem. Okay. Supercharging also very important. Filling up the cylinder completely with the air fuel mixture. Okay, that gives good output, but over supercharging sometimes leads to detonation, tendency of the detonation. So you have to maintain the optimality. Next to coolant temperatures. Coolant temperatures are very important. Delay period decrease in the increase of the coolant temperatures. Okay. So decrease the delay period, increase the tendency of knocking temperature. So how to maintain all the parameters. Next to density factors also. Density. Okay. So density of the fuel. So increasing the density of unburnt mixture will increase the possibility of knocking in the engine. Okay. So the engine parameters which affects the density are as follows. Okay, increased compression ratio, increase the density. If we increase the compression ratio here, you know that VC by total volume. Next, increasing the load, increasing the load opens the throttle valve more, and thus density of the charge will be increased. Next, supercharging. Supercharging increase the density of the mixture. Okay, so density of the mixture in the cylinder increases. So if the density increases, automatically the density of the fuel influences the temperature, influences the supercharging. Okay. So all these things we have to. It means over density leads to knocking problem. Next, time factors also very important. Increasing the time of exposure of unburned mixture that leads to auto ignition. Okay. So we have to maintain certain time for the flame propagation. So these are the different factors. Next, flame travel distance is very important parameter. So flame travel distance. So if the distance of the flame travel is more, automatically that leads to uh, knocking. Okay. So then possibility of knocking is also more. So the rate of flame propagation should be more. If the distance of the flame travel is more, it means if you if we take the large diameter of this, if you increase the CC, automatically that leads to some mm, knocking tendency. Okay, this problem can be solved by combustion chambers design. Designing of the combustion chamber is very important. Next to positioning of spark plug loop or location of the spark plug also very important. Next, size of the engine also increases. If you increase the size, automatically that the distance of flame travel automatically increases. If it is increases, that leads to or that causes to possibility of knocking. Next, location of spark plug also very important portion. A spark plug which is centrally located in the combustion chamber, so that has minimum tendency to knock, because if you take centrally, automatically flame propagation would occurs properly in short time. That leads to decrease in the knocking problem. Okay. So a spark plug which is centrally located in the combustion chamber, so has a minimum tendency to knock. So the flame travel is minimum. Okay, so flame propagation time reduces by positioning of the spark plug at the center of the cylinder. Okay, the flame travel can be reduced by using two or more spark plugs also. Okay, you can use uh, two or more spark plugs. Position of the spark plugs, and we are using the more number of spark plugs, we can reduce the flame travel distance. Okay, so automatically we can reduce the tendency of knocking. Next, location of exhaust valves. Exhaust valve location also very important. The exhaust valve should be located very close to the spark plug, so that it is not in the end gas region. Otherwise, there will be a tendency. So, due to the effect of by we know that by the effect by exhaust valve, so uh, unburned fuel particles or exhaust gas will exhaled or will exhaust to the outside. Okay. So then automatically you know that 40 to 50% of heat will be exhausted by exhaust gases through exhaust valves. Okay. So positioning of exhaust valves also very important. Next, engine size also very important parameter. By controlling these sizes, we can reduce the tendency of knocking. Okay, large engines have a greater knocking tendency because flame requires a longer time. So, because large size means flame travel distance is very high. If the flame travel distances increases, automatically the tendency of knocking would increase. So these are the very important parameters we have to consider when designing the engines, uh, preparing the engine cylinders. Okay. So due to the abnormal combustion, which is main the problem that knocking detonation occurs due to auto ignition or pre-ignition. Okay. So we have to address that problem. To overcome that problem, we have to take care in some influencing parameters like flame propagation distance, location of the spark plug, location of the exhaust valves, engine size also. Next to delay timing, time factors, density factors, we have to consider this one. Next to temperature factors also. So all these factors we have to consider. So by controlling these factors and based upon the uh, optimality of so optimality of these factors, just to, so we have to design the engines. Okay, so by considering all these factors, we can reduce the knocking problem or it means detonation problems. Okay. So then we'll get the normal combustion process in the ICE engines. So thank you for listening this class. So these are the references.
Like, share and subscribe. Hit the bell icon for more updates.